Hello friends, today we are going to see certain fundamental aspects of working for the core manufacturing industry. What are the various product domains and the functional roles that we mechanical engineers can possibly take up in our career? Among the various branches of engineering, mechanical engineering provides the most extensive opportunities to work across multiple broad spectrum of areas. As fresh engineers, it is good to know these so that we can place ourselves in a better position. You all know we can excel in our work if domain and role matches with our taste, passion, trait and interest. Today's discussion has three major parts: the product domains available, the manufacturing processes used, and the functional roles available for us to pick. I am going to use the mind map for navigation in this discussion. The product domains, there are three groups: the process manufacturing group, discrete manufacturing group, and government dominated manufacturing group. Process manufacturing industries produce bulk output for general consumption. Smelting ores into metal like iron, aluminum, copper, etc. is a primary example of process manufacturing. Producing bulk materials such as cement, gypsum and ceramic goods involve process manufacturing too. Petroleum industry follows with many activities from extraction to refining to distribution. The byproducts of petroleum lead to making soaps, paints, plastic resins, etc. in bulk. Textile industry is another processing major. Semiconductors too. Fast moving consumer goods like beverages, processed food, etc. fall into another major process manufacturing industry. The key points to understand here are: process manufacturing is naturally a large scale manufacture and the location of the factories is primarily dependent on the availability of raw materials. Mechanical engineering provides the backbone infrastructure, the plant and machinery to run these process factories. Engineers' role in such a process engineering environment is in the selection, procurement, installation, operations and maintenance of the plant and machinery. A lot of opportunities exist for the diploma level engineers in such process based industries. The output product is not a mechanical engineering product, so advanced engineering design and technology have limited role to play in this. One major group in discrete manufacturing is the machinery and industrial products group, which actually supplies plant and machinery to the process manufacturing industries in a big way. Earth moving and construction equipment, material handling equipment, compressors, pumps and valves are some of these products. The automobile industry is a large segment with a very high emphasis on advanced technologies. Appliances industry provide opportunities for large scale manufacture of devices for modern living. There are technology products such as smartphones and computers. Medical devices are high value, high precision, multidisciplinary products. Aerospace led the development of many modern CAD/CAM CAE tools, opening up a specialized breed of engineers with software focus. It is good to know that in the discrete manufacturing, both process and product has a lot of influence from mechanical engineers. This way, these segments provides the maximum opportunities for the involved, passionate and creative mechanical engineers to work and deliver the best results possible. Unlike process manufacturing, the discrete manufacturing industry supports a network of supplier industry and thus enables the entrepreneurship at the smallest possible level. One can start an industry supplying parts to a large discrete manufacturing company. Engineers gaining experience and knowledge can easily move around multiple companies and in multiple allied roles. Thereby, the cross fertilization of knowledge benefits the community as a whole. There is always a product or technology that can feed the interest of every engineer. Railway products are locomotives, coaches, track infrastructure, and signaling devices. Power generation, transportation, and distribution uses a lot of equipment and devices. Defense equipment is a high value advanced technology industry. Ports and shipping related equipment as well as mines are all examples of government dominated manufacturing activities. In government dominated manufacturing, limited freedom exists for the product designs. Also, the nature of organization makes it difficult for the job rotation, making this less attractive for the creative minds to work in this domain. We are going to focus more on the discrete manufacturing sector hereafter, which gives the most opportunities for the mechanical engineering community. Let us understand what core processes are behind these manufacturing units. We have sheet metal stamping, which is a large volume light engineering process, and similar is the plastic injection molding, again large volume process used in light engineering. Then different types of aluminum die casting, then followed by light machining of such parts, and if required we do CNC machining of parts in the heavy engineering side. Then we have foundries manufacturing castings of different metals and alloys. We have forgings doing hot and cold forged parts. Then we have laser and gas cutting process that cuts different sheets and plates. We have press brake bending for bending these sheets and plates. Then they are either light fabrication processes or heavy welding fabrication processes we follow. It's too overwhelming, isn't it? The product domains, the manufacturing processes are really a very big list of things for a fresh engineer. Whatever extent possible, try to grasp. There is no need that everything has to be understood in a single go. Also, the manufacturing processes explained where starting from very light engineering to the heavy engineering end of the thing, we have touched upon various processes. Depending on the type of industry, a subset of this would be available to any place, any company. For example, a supplier industry may have only very few of these. A large industry may have a handful of these, and if it is a process manufacturing industry, it may not have much. So depending on where your focus is, you have to understand these. Next, we are going to see the engineering functions we engineers have to take up in a manufacturing organization. Let us go through that. Product domains, manufacturing processes, and now engineering functions. Engineering functions are three major group of functions: marketing functions, product design and NPD functions, and manufacturing functions. Marketing functions are typically 3 or 4 functions in marketing team: the product management function, application engineering function, sales, the direct frontline sales function, then service related functions including training, everything. Then comes product design and NPD functions. This is an elaborate list which has R&D, the tryout of new ideas and innovation, design, the 3D modeling environment, simulation, the CAE, proto build, the physical building of prototype, testing and validating the prototype, documenting and releasing the design to production, and continuous engineering, all sustenance engineering. The manufacturing team contains manufacturing engineering function, supply chain and logistics function, facilities and automation function, quality engineering function, feeder shops and assembly shops have to be managed, then plant engineering function. These are the various functions. Too short time for explaining all the roles in this session. I believe it is possible to have a separate explaining in detail all the roles. and I'm sure this session is a useful one for all of you. Let us meet in another session. Bye bye.